Good afternoon. Today we're going to talk about Lewis dot structures for both ionic and covalent compounds. Now we're going to start out with covalent compounds, and just a quick review. A covalent compound is where we have the atoms that are both nonmetals. So let's examine how to draw a Lewis dot structure for a covalent compound, such as NH3. First thing we have to remember is that the lone atom is always a central atom, all the time. So in NH3, as you see here, nitrogen's a lone atom. He is my central atom. And I have to put my valence electrons around my nitrogen. If we look here, nitrogen has 5 valence electrons, and I have my 5 dots around nitrogen right there. That's a good place to start. Now, when we have 1 electron around the atom, I call that an open site. If there's 2 electrons on that side, it's not an open site. If it's 0, it's not an open site. 1 electron by that atom is an open site. And there are 3 open sites in my nitrogen atom. And wouldn't you know that NH3, hydrogen has 1 valence electron, and there are 3 of them. So I'm going to take the hydrogen and its valence electron and put it right next to the open site. And I have my NH3 right here. And 2 electrons are equal to 1 bond. Don't forget that. 2 electrons, 1 bond. And that's my Lewis structure for NH3 right there. Now I'm going to ask you to re-examine or examine CCl4, carbon tetrachloride. Now if we look at carbon, carbon has 4 valence electrons. We see it right here. And we draw the Lewis structure, that's what carbon would look like. There are 4 open sites. But wait a minute, it's C with a Cl4, 4 of them. Chlorine has 7 valence electrons, as we see here and here. So we take the open site of the chlorine and attach it to the open site of the carbon, and we do that 4 times, as you can see over here. And there is a bond here, a bond here, a bond here, and a bond here. CCl4 would look like that. Now HCl, again, hydrogen with 1 valence electron, chlorine with its 7, they get together and they make that bond. You try it with pH3. I gave you a head start. Phosphorus has 5 valence electrons. Hydrogen has 1, and I only drew 1 of them. So I'm going to give you 8 seconds, and you're going to give it a shot to do pH3. Awesome. Now, let's try H2 and H2O. Oh, I did them for you already. Sorry, guys. H2 looks like this. H2O looks like that, which is a good place to start. Now, what if a compound or an element has a double bond? Oh my God, what do we do? Well, first of all, we'll start out with oxygen, O2. Oxygen has 6 valence electrons, and we look here, 6 valence electrons there. There are 2 open sites, which tells you oxygen will always form 2 bonds, whether it's 2 single bonds or 1 double bond. But we're talking about O2, so oxygen is going to bond with itself. So here's 1 oxygen, here's another oxygen. And those open site electrons bond with one another, forming a double bond, which you see here. That bonds with that bonds with that, and they get a double bond over there. Now I'd like to do questions 1 through 4. And I think you might, as you go through it, just turn off the mic for a minute or 2, do them, come back, and I will give you an update on how to solve those problems. Okay, now I'm guessing that you're back. So let's take a look at question number 1. Question number 1 says, given the Lewis dot diagram of CH4, which electrons are represented by the dots? Well, heck, you know, the carbon brings its valence electrons to the table, and so does hydrogen. So it's the carbon-hydrogen valence electrons. Next, what is the total number of electrons shared in a double bond between 2 atoms? Well, we know 1 bond is always equal to 2 electrons, so 2 bonds would be equal to 4 electrons. Next, how many shared electrons are shared between a nitrogen atom and a molecule of N2? Well, heck, there we have a nitrogen right there. Now watch this. I'm going to copy, I'm going to paste that, and now I have another nitrogen over there. Now we have 3 open sites on each nitrogen. What do? Well, they bond with each other. So nitrogen will always form 3 bonds, and when it's with it in itself, it's a triple bond. So how many shared electrons are there in the nitrogen molecule of N2? Well, you know there's 3 bonds, so therefore there must be a total of 6 electrons. Lastly, which of the following Lewis structure does not represent the molecular compound? Please, please, please remember, molecular means covalent. There are no metals in that structure. So molecular must be covalent. But it's asking which does not represent a molecular compound. Well, if we look here, okay, we see that there's no metals there, so that's molecular. We see that there is no metals here. That can't be it. So lo and behold, metal, non-metal, and that's your answer. Awesome. Now, we're going to do how to draw Lewis structures for an ionic compound. For this one, we need brackets and charges. We always look in the upper right-hand corner for the charge of the element. Take the first charge unless you're told otherwise. So I'm going to ask you to draw the Lewis structure for BaCl2. Remember, metals are the biggest losers. They lose their valence electrons. So when you, in fact, draw this, you just write the metal with its charge. So for Ba, all we're going to do is we're going to write Ba2+. Now chlorine. Nonmetals always form an octet. They always have 8 electrons around it no matter what. So if we look at Cl, I write Cl with 8 valence electrons. And there's my minus. And when I put it together, I write my Ba2+ and my Cl-. But I have a 2 over there. Why might that be? Because when I look at my BaCl2, there's 2 chlorines, and I got to show the 2 chlorines, so I put it right in front of the Cl. Now what I'd like you to do is I'd like you to take a look at NaF, CaCl2, and Al2O3. I'd like you guys to try to write the Lewis structure for that. And when you're done with that, do questions 5, 6, and 7, and then run through the part 2s. I'll leave it at that. Have a nice night.